Good day, everybody, and we meet yet again. And today we are going to be studying or looking at the fertilizer industry. Okay, this is the last chapter for those of you who are in South Africa and doing grade 12. So, this would be the last chapter in chemistry. Now, what I'm going to do is just to give you the nuts and bolts of what you need for this particular chapter. So I'm going to trim out quite a lot of things, unnecessary information, so that you end up with just what you need for the examination. Of course, you can always refer to textbooks and other material if you want to get further information. But for the purpose of preparing for our examination, I'm just going to just trim it down to the nuts and bolts. Okay, so for those of you who haven't subscribed, welcome, and by the way, become a member of the family. Okay, and by the way, just give a thumbs up to this lesson if you liked it, and yeah, let's dive right into it. Okay, right, so first of all, when we talk about fertilizers, right, we know that these are essential elements for the growth and for the health of any plants. So whenever we plant, we've got fertilizers to help us with the growth of plants and to make sure that we produce food much faster. Okay, so essentially, what I'm going to begin or to start with is essentially, what do we use fertilizers for? Okay, or in this case, to talk about the essential elements in fertilizers. So essentially, when we break down fertilizers or when we break down nutrients in plants, we've got differences between basically what we call non-mineral nutrients as well as mineral nutrients. Okay, so let me just break it down to you this way. So we've got essentially what we call macronutrients. Okay, so we've got macronutrients in plants. Okay, so nutrients are what plants need in order to grow. Okay, but when we look at macronutrients, we've got non-mineral nutrients. Okay, all right, you'll understand this in just a bit. So we've got non-mineral nutrients. Okay, and we've got on this side, just to give ourselves a little bit of space, okay, we also have mineral nutrients onto this side. Okay, so so these are mineral nutrients. Okay, so in this particular case, what we're going to do is we're going to make sure that we understand. All right, on this side, what do we have? We've got carbon. All right, so under our non-mineral nutrients, we've got carbon. Okay, we've got hydrogen, and we've got oxygen. So I'm not going to talk really much on this side since the fertilizer industry that we talk about mostly, we are actually referring to mineral nutrients. Okay, and in this case, these are absorbed from the soil. Now, if you think about this, plants actually get this from air and from water, right? Water composes of hydrogen and oxygen, and obviously there's carbon there as well, right? So when we talk about non-mineral nutrients, in this case, we've got nitrogen, we've got phosphorus, and we've got potassium. So we call it NPK, right? So that's nitrogen, phosphorus, and potassium. Okay, right. Now, obviously under non-mineral, you also, in fact, you've got two types of non-mineral nutrients. You've got primary nutrients. So usually we call these primary nutrients. Okay, so these are primary. And we also have secondary nutrients. Okay, actually I didn't want to refer to that, but let me just include it whilst I'm at it. Right, so we've got secondary nutrients, which we're not really going to delve in so much. Okay, so we've got secondary nutrients, and under that, you look at things like calcium, you've got sulfur, as well as magnesium. So you can look at magnesium as well as sulfur. Now, please, I want you to note, in this case, for the purposes of what we are going to do, we're not really going to focus on this guy, neither are we going to focus on that, but we are going to look at the primary nutrients. Okay, so that's nitrogen, we've got phosphorus, and we've got potassium, right? So first of all, let's talk about the function of each when it comes to plants before we talk about the manufacturing of them. So nitrogen, if you look at it mostly, is used essentially for the growth of leaves, right? So this we use for leaf growth. So if you think about your spinach, okay, in order for you to plant things like spinach, okay, you'd need quite a lot of nitrogen there, and it would help in the growth of leaves, okay, and any other plant for that matter that requires leaf growth. Okay, as I said to you, there's many other things that I could say about this, but I'm just going to give you what you essentially need. And then we've got phosphorus that we use for root growth. So I want you to remember, anytime that you think about phosphorus, that's responsible for the growth of roots. Okay, so by the way, if you think about plants that have to do with roots, for instance, like potatoes, like your carrots, okay, to make those kind of plants grow, you would need a lot of phosphorus, right? So if you think about this, okay, let's just imagine if you talk about potato, okay, so P for potato, and you can take that N for spinach, okay, spinach. You think about spinach, okay, so and the last one there, we're talking about potassium. And in this case, we say that potassium, we use it normally for the growth of flowers. So this is for flowering. Okay, so for flowers and fruits. Okay, there are some plants. Sorry, I wanted to write fruits there. Okay, so we use this for flowers and fruits. Okay, so there are some plants that actually produce flowers, and the moment that the flowers kind of appear, they sort of get easily burnt by the sun, or they have spots on them. That would be diseases in plants, right? So you would actually need potassium in order to make sure that they grow in a healthy manner. Okay, so these are the three primary nutrients. Okay, and now what we're going to do is we're going to look at the fertilizer industry. How actually are these nutrients or produced? Okay, now of course we've got organic nutrients, we've got organic fertilizers, okay, that can be used from nature. But in this case, we're going to look at the synthetic manufacturing, meaning how do they produce nutrients or these primary nutrients from a synthetic process, from a chemical and industrial process. Okay, so let's get into that. Okay, so the first industrial process that we're going to talk about is called the Haber process. I'm not sure if some of you prefer to pronounce it as Heber. Okay, if you do, well, that's really up to you. Okay, so in this case, in the Haber process, we want to produce, or this is the process that is used for the production of ammonia. So NH3 is the product over here. Okay, so it's a simple process, by the way, that involves the reaction between nitrogen and hydrogen. Okay, so in fact it's just nitrogen, which obviously is a gas. Okay, and 3 hydrogens, okay, obviously, which is also a gas, and they produce this product called ammonia. Okay, which is quite important for the formation of fertilizers. You'll remember, ladies and gents, that remember all that we are trying to do is to produce fertilizers, All right, so we are getting into that. And this is all that is necessary. So this is quite a very instrumental a product that we use for the manufacturing of fertilizers. Right, so this is the Haber process. Now the thing about it that you have to just remember the conditions, and I'm going to just write that in a different color. Okay, so in the Haber process, just remember that we use a catalyst, and that catalyst is iron, or sometimes they even use iron oxide. Okay, so I'm just going to write there FeO, or iron oxide, okay, which is a catalyst that is used there. And by the way, we should also remember that this is an exothermic reaction. Delta H is less than 0. Okay, so meaning that heat is produced in the process, right? That's quite important. Now, one of the things that they always, or they often like asking, is where does the nitrogen come from? Now, please always remember that nitrogen is actually produced from a process called fractional distillation of air, right? So we call it fractional distillation. Okay, so in this case, just remember that they get nitrogen from the air that we breathe. Remember that the air that we breathe is actually 78%, okay, nitrogen. So 78% of air contains nitrogen, and that is where they actually get the nitrogen that is used in that process. Okay, right, so remember that iron oxide is the catalyst, so that is something that you should always bear in mind. And some of the other conditions that we just need to keep in mind, but look, these are not really important. I'm not too sure if they'll ever ask us any information about it. So this takes place at a moderate temperature of about 400 to about 500 degrees Celsius, okay, and at about 200 atmospheres of pressure, okay, so that's 200 to 300 atmospheres of pressure. Now, please, I want you to note these are not so important. I think the most important thing that you need to remember is the fact that iron oxide is used, and obviously in mild heat, okay, of 400. Well, not, you don't need to be specific about the actual number, but it takes place in mild heat. Now let's go to step number 2, or rather the next process in the fertilizer industry. And what we'll do at the end, we'll just consolidate all of them and show you how those fertilizers are formed. So process number 1, we had the Haber process. Let's go to process number 2. So in process number 2, we've got the Oswald process, okay. So it's the Oswald process. Okay, just keep that in mind. That's the name of the process. Right, now what are we trying to produce in the Oswald process? Here we are producing nitric acid. So I wrote this incorrectly there. So we are producing HNO3, nitric acid. And I'm going to take you through the 3 processes, okay, that that are involved here. So step number 1, okay, so this is called, by the way, the catalytic oxidation of ammonia. So what they simply do is that they take ammonia. You remember that we just produced ammonia, so that ammonia can be used in this step here. So ammonia reacts with oxygen, okay, to form in this case nitrogen monoxide, okay, and water. Now, very deliberately, I just gave you a step there and I didn't balance it, okay. The reason why I did that is that I wanted to show you quickly just how to balance that, okay, so that you can be able to do that in the future. I've seen a question where they asked you to write down the balanced form of this reaction, okay. Now, just a quick reminder, they use platinum here as a catalyst, okay. Remember I said I'm going to always write that in a different color, and obviously this takes place at about 900 degrees Celsius, okay. So It's also an exothermic reaction. Okay, so delta H is less than 0. So I want to show you quickly how to balance this reaction. So if you think about it, so we've got one nitrogen over here. You've got one nitrogen over there. So I'm showing you a lesson on how to balance now, right? So one nitrogen, but you've got three hydrogens over there, and you've got two over there. So how do you make sure that the number of hydrogens over this side is the same as that side? So what I'm simply going to do is I'm just going to make sure that, okay, I even these ones out. Okay, so I'm just going to say, all right, so that's 2 there, but note, remember, when you balance, you only put coefficients here, you don't put numbers at the bottom, right? Because that changes the molecule altogether. So it means in this case, now I've got 2 nitrogens. Can you see? So in this case, I need to adjust that guy and say, well, 2 nitrogens, I've got 2 nitrogens. Now I've got 2 times 3 hydrogens, which is 6. All right, how do I make this one 6? I think you're getting it now. Okay, so I'm going to actually multiply that by 3, right? So 2 nitrogens, okay, 6 hydrogens, 3 times 2 hydrogens, that's 6. So hydrogens and nitrogens are okay. But now, notice, I've got 2 oxygens on the left. And how many do I have on the right? That's 2 times 1, that's 2. That's 3 times 1, that's 3. So that's 2 plus 3, that will be 5. Okay, so notice in this case I've got 5. So how do I make this one 5? What multiplied by 2 will give me 5? Obviously that's 2.5. That's 5 over 2. However, ladies and gents, now I want you to look at this. So 5 over 2 multiplied by 2 will give me 5. However, please remember that you can never express a chemical equation, right, with fractions, or leave it with fractions, or in this case decimals. Okay, so what I'm going to do is just make sure I get rid of the fractions there, all right, by multiplying by the lowest common denominator, and in this case our lowest common denominator is 2. Okay, so I'm going to multiply everything throughout by 2. So what do I have? 2 multiplied by 2 will give me 4. So I've got 4 NH3, right? So I'm going to have 4NH3 plus 5 over 2 multiplied by 2. That should give me 5. Okay, 5 oxygens. All right, and then what do I have now? On the other side, multiply that by 2, that will give me 4. Okay, so that will be 4 nitrogen monoxide. Okay, I'm using 2 different colors here. Okay, so 4NO, and then obviously 3 multiplied by 2, that should give me 6. So in this case, I've got 6 H2O. So that is how you would balance that. I did that with you. Okay, I'm taking the time to go through that with you so that you can see how to do it. Okay, in case it is ever asked in the exam. So we call this step the catalytic oxidation of ammonia. You must remember that. Remember, everything that I'm giving you, ladies and gents, are exactly what you need for the exam. Now let's go to step number 2. Okay, so let's go to step number 2 in this process. So what happens in step number 2? Remember, we are trying to produce nitrogen monoxide. We're not there yet. We've just produced nitrogen. We're trying to produce nitric acid rather. So we've just produced nitrogen monoxide. So now what's going to happen in step number 2 is that we take that nitrogen monoxide. Okay, I'm just going to give you a balanced form of this reaction. So 2NO, and we react it with oxygen again. So in step number 2, you react it with oxygen, and what do you get? Okay, and this gives you nitrogen dioxide. Okay, so that would be step number 2 of this reaction. Okay, we've just produced nitrogen dioxide. Now, just to remind you again, remember this delta H is less than 0 again for this reaction. Okay, as well as that one, delta H is less than 0. Okay, I'm not too sure if that is important for now. Okay, right, now that would be step number 2. So in step number 1, we produced nitrogen monoxide. In step number 2, we produced nitrogen dioxide. And the last step of the Oswald process, right? So all that we are doing now, we are taking that nitrogen dioxide now, we react it with water. Okay, so again, it's going to be, I'm going to give you a balanced form of this reaction. Okay, otherwise I could have actually also showed you how to balance it. So that's 3NO2 plus H2O. Okay, so just remember it's oxygen, oxygen, water. Okay, and what it simply gives us would be NHNO3, so that would be nitric acid. Okay, now you also produce nitrogen monoxide again in this step. Okay, so in this last step, you produce nitrogen monoxide, which is fed back into the second step again. Okay, now perhaps they might ask you this step by step. You just need to, and there's no other way of remembering stuff here except just through memory. Okay, so you just have to commit this to memory, as much as I have done so in the past. So in this case, we've just produced what we wanted, which is nitric acid. And by the way, you'll see how all of this comes together once we get to the final step. Okay, so now let's go to step number 3. So now we've produced nitrogen and nitric acid. That's the Oswald process. And remember that the catalyst that is used there is platinum, or they also use rhodium, by the way. It's either platinum or rhodium. Okay, and those are used for the production of nitrogen monoxide there. Now let's go to step number 3 quickly. All right, so step number 3, we call it the contact process. Okay, so or rather, let's call it process number 3. So we call that the contact process. Okay, now we're going to talk about what happens in the contact process in just a few. So here we are trying to produce sulfuric acid. Okay, H2SO4. So that is what we are producing in the contact process. Now, just to quickly show you what happens in the contact process. So we've got essentially it's 3 steps, but what happens is that it's now broken down into 4, and I'm going to explain why that is the case. All right, so step number 1 in the contact process is that sulfur burns in oxygen. Okay, so you've got sulfur that burns in oxygen, and to produce sulfur dioxide. So that's step number 1, and it's quite easy, it's straightforward. Okay, so sulfur burns in oxygen. And then step number 2, what you then find is sulfur dioxide again reacts with oxygen. Okay, all right. By the way, all of these are gases, right? So it produces sulfur trioxide. Okay, but of course we need to balance this reaction. Okay, so in this case that would be 2 here, and that would be 2 there. Okay, I'm not going to waste time on that. All right, you can just commit it to memory. So sulfur dioxide reacts with oxygen again, and it produces sulfur trioxide. Now the third step is what I actually want to just dwell on just a little bit, just to explain to you what happened here. So when you take sulfur trioxide and you react it with water, if you think about the previous step, we took oxygen, we took ammonia, reacted it with oxygen, we took which produced nitrogen monoxide. We took nitrogen monoxide, reacted it with oxygen, we produced nitrogen dioxide. And in the last step, that nitrogen dioxide reacted with water, so it's almost oxygen, oxygen, water. This kind of this step kind of would have been the same. However, what then begins to happen is that when you take SO3, sulfur trioxide, and react it with water, what happens is that it forms a mist, a huge cloud of smoke, right? So that mist is actually sulfuric acid which is forming. Now, if you think about sulfuric acid, it is a dehydrating agent. So, in a sense, that sulfuric acid starts reacting with the water and it becomes this huge mess. Okay, so it forms a mist, which is sometimes very difficult to collect. So now, not even sometimes, it's actually difficult to collect. So in this case, what they're going to do is that now they take sulfur trioxide. So instead of reacting sulfur trioxide with water, now we're going to take sulfur trioxide and we are going to react it with sulfuric acid. Now, you think about it, we're trying to produce sulfuric acid, okay? But we are using sulfuric acid, okay? So they use dilute sulfuric acid over here, okay? And what it then produces is a product, okay? H2S2O7. I always need to make sure that I say this out loud so that I remember it, okay? This stuff over here is called oleum, all right? As I said, ladies and gents, I won't mention it unless it's important, okay? So just keep that in mind, okay? So oleum, or sometimes even called pyrosulfuric acid, but I prefer oleum. It's easier to remember, okay? Now, something that I almost forgot to mention is the reason why this is called the contact process is because of this second step. Now, these guys are all gases, right? And they come in contact process with a catalyst, and the catalyst that is used there is vanadium pentoxide, okay? Just keep in mind it's in this step here. So they use a catalyst called vanadium pentoxide, okay? So essentially then we go to step number 3, where we took sulfur trioxide, we reacted it with sulfuric acid, okay? We formed oleum or pyrosulfuric acid, and now they dilute this pyrosulfuric acid with water, okay? So that would be step number 4, okay? Right, all this to try and avoid, you remember when we were talking about that cloud of smoke or mist that forms, so to avoid that, and it's very difficult to collect that. And in this case, what happens is that pyrosulfuric acid, oleum, is now reacted with water, okay, H2O, and what we find there is sulfuric acid. So it forms 2H2SO4. Okay, so that's 2H2SO4. And by the way, just keep in mind, they've asked this in the past, that sulfuric acid is 98% pure, okay? They have asked in the past about percentage purity, okay? So this is the last process that we are going to actually mention under this section. Now, let's bring it all together and get to the end of it, okay? Now, how do we get to the conclusion? So remember, now we have formed fertilizers, right? And the fertilizers that we're going to form, or rather we are going to form fertilizers, the fertilizers that we're going to form, you remember the first product that we have in the first process, right? Ammonia. If we react ammonia with nitric acid, okay, we get a fertilizer there, okay, which is a nitrogen-based fertilizer, and that fertilizer is simply NH4, that's ammonium nitrate, okay? So we get that fertilizer over there, okay? So this guy we can now use to nutrify plants, okay? Because you remember that plants do need that as a as a primary nutrient, okay? Right, let me show you just other fertilizers just as an example. Okay, so if I take ammonia, for instance, and I react it with sulfuric acid, H2SO4, Okay, now ladies and gents, I want you to just remember something. I'm not going to give that in full. I just want to show you the fertilizer form of it. Okay, so I'm not going to write down the full reaction, just for you to appreciate, ladies and gents. So when you look at the amount of hydrogens there, this is an acid, right? It has only one hydrogen over there. So meaning that even when it reacts with ammonia, you're going to have only one NH4NO3. So because this guy is plus and this guy is minus, right? But when you take H2SO4, sulfuric acid, now the product that is formed, and deliberately I'm giving you this because I've seen a question where they ask you to write down the formula of the fertilizer that is formed. Okay, right, perhaps in the future what I will do is that I'll just take a past exam question and show you how to answer questions here. So that's NH4, but it's going to be 2 at the bottom there. So you basically just substitute the hydrogens with the ammonium, okay, ion, so SO4. So this would be the type of fertilizer that is formed. Okay, so it's a sulfur based fertilizer. And then I can take just another one just to show you quickly there, NH3. If I take a phosphate type of fertilizer, if I just react this with H3PO4, which is phosphoric acid, right? So phosphoric acid is written in that format there. Okay, so that's H3PO4. As I said, ladies and gents, so the hydrogens would be replaced by the NH4. Okay, just remember, if I write down that expression there, so that would be NH4. Remember, there were 3 hydrogens, so in this case it's going to be NH4 3PO4, and this is the fertilizer that is formed. Okay, right. So ladies and gents, what I quickly want to do now is just get to the conclusion of this. I wanted to limit this as one video. I could have actually just produced another video on this, okay, but I'm just going to limit it to just the reactions, and then just to quickly talk about the NPK ratio. Okay. All right, so as a conclusion to this section, I just want to quickly talk about eutrophication. Perhaps what I'll do is that I'm going to produce another video on NPK ratios, just how to calculate that. Perhaps that will be much shorter. I think I want to conclude this with just talking about eutrophication. Okay, so what is the effect of using inorganic fertilizers, right? Well, it's actually something called eutrophication. And what is eutrophication? It's basically the absence of oxygen in the environment. So if you think about the fertilizers that we use, you know, they run through what we call agricultural runoff. So as rainwater comes in, and it goes to the drains and it goes to the rivers and so on. So now there's an excess of nutrients now in the water, okay, which causes the formation of algae. So just remember, eutrophication is the absence of oxygen, okay, or in this case the deficiency of oxygen in the environment. So what happens is that now we've got deficiency of oxygen. Why? Because the formation of algae now uses up the oxygen inside the plants, okay, rather inside the water, and that means that, you know, obviously that the species that live in water now don't have a sufficient amount of oxygen, okay, so as a result, you know, they end up dying. So obviously, just like everything, we need to use them responsibly, okay? So when we use fertilizers, we just need to make sure that we are aware of the consequences, of using these fertilizers. And by the way, what about, the impact on humans specifically, okay? So what happens with humans is that babies develop a condition called blue baby syndrome. Okay, so if you think about it, deficiency of oxygen, that's eutrophication, and as a result we end up with blue baby syndrome. Okay, you can just quickly Google that for yourself. Okay, all right. So it's a condition actually that's caused by the deficiency of oxygen in the blood. Okay, so that would be the impact. Those are some of the impacts of using fertilizers. Okay, so I just hope, ladies and gents, that this lesson would be. I want to leave it here. Okay, and what I'm going to do, as I said, I'm going to just pick it up from here and talk about the NPK ratio on our next lesson, just to make sure that you have an overall understanding on how to do calculations in this section. Otherwise, please, if you like this lesson, please just give a thumbs up. As I said, ladies and gents, there's no other way of remembering this except for you to go through it. Okay, I've just tried to give you some pointers on how to go about this section, but ultimately you just need to remember everything. Okay, and then the culmination of it, or rather at the end of it all, I'm going to just do a section. Okay, I'm going to do past exam questions as we prepare, right, for our examination, just to show you how to tackle questions on this section. All right, otherwise it's goodbye from me for now, and I'll see you guys next time. Sharp, sharp.